Hello class, welcome to lesson 6.5, which is all about applying systems of linear equations. By the end of this lesson, you should be able to determine the best method for solving systems of equations, and you should be able to apply systems of equations. So this chart right here is something that you will likely want to take a screenshot of because it helps you determine what method we've learned so far is the best choice for each situation. So the graphing method is used when you just need to estimate a solution. It's when you don't need an exact something, since graphing usually doesn't give you the exact solution. I'm going to be honest, you don't often choose the graphing method, okay? Usually if you have to graph it, I tell you and I put a chart there for you to graph it on. What you do really need to focus on is being able to remember how to tell when to use each of these four. So remember, you use substitution if one of the variables in either equations has a coefficient of 1 or negative 1. So if I have an x plus 4y equals 7 and a 3x minus 2y equals 9, the very first equation, I have a 1 right in front of my x there. This would be a good example of when to use substitution. You would solve for x. So this would become x equals negative 4y plus 7. Okay? Elimination using addition. Elimination using addition is good when you have one of the variables that has opposite coefficients in the two equations. So what that means is if I had a 2x minus 4y equals 7, and a negative 2x plus 8y equals 7. I have a positive 2x and a negative 2x. This is where I would add, okay? I would subtract, however, if these were both negative 2x's. So if I had a negative 2x and a negative 2x, that is when I choose to subtract the entire bottom equation, okay? When do you use multiplication? This occurs when none of the coefficients are 1 or negative 1, and none of the coefficients match. Okay, so if I had 3x plus 4y equals 9, I had 7x minus 2y equals 11. I have a 3, a 4, a 7, a 2. None of those are the same. So that means that this is where I would have to multiply by something in order to get an identical coefficient that would cancel. Okay? So let's look at our first problem here. We want to determine the best method to solve the system of equations, and then we want to go ahead and solve it. So the first one we have is 5x plus 7y equals 2. We have a negative 2x plus 7y equals 9. Okay, so I see right away I have a 7 and a 7. So they are the same coefficient with the same sign. So that means we can use elimination by subtracting. Oops, that should not be a minus 1. That should just be a minus sign. So I'm going to use subtraction elimination in order to solve this. So I'm going to go ahead and subtract everything here. So I have 5x minus a negative 2x. That becomes 5x plus 2x. So we have 7x. 7y minus 7y. That just becomes 0. 2 minus 9 is negative 7. So my x equals negative 1. If I plug negative 1 back in, I have 5 times negative 1 plus 7y equals 2. So I have negative 5 plus 7y equals 2, or 7y equals 7, y equals 7. Oh, not 7, 1. That is something I see you guys do when you try to rush, though, where you will accidentally make a silly calculation error like that. So make sure you take some time and check your answers. So then, writing it as an ordered pair, we have negative 1, 1 as our answer. Let's look at our next one over to the right. We have 3x minus 4y equals negative 10. We have 5x plus 8y equals negative 2. I have a 3, 4, 5, and an 8. None of those are the same, so I'm going to use elimination. And I'm going to use multiplication. And I have to figure out what do I need to multiply by in order to have something cancel. 5 and 3 can't multiply into 5, but 4 can multiply into 8. So I'm going to multiply everything by 2. So I'm going to have 6x minus 8y equals negative 20. And then this one just carries on. Now I have two signs that are opposite of each other, so that means I'm going to add. Now, so I have 11x equals negative 22. X equals negative 2. If I plug negative 2 in, I can say 3 times negative 2 minus 4y equals negative 10. Or negative 6 minus 4y equals negative 10. Negative 4y equals negative 4, or y equals 1. Okay, so then I go back and I say negative 2, 1 is my answer. Okay, now I'm going to continue on if it will let me scroll. It's not wanting to, so let's see. There we go. So this next one in the bottom left-hand corner, we have x minus y equals 9 and 7x plus y equals 7. I see that I have my two y's that are already set up to cancel if I use elimination, and I just add them. So that's what I'm going to do. I'm going to add these two equations together. I have 8x equals 16, or x equals 2. And then I have 2 minus y equals 9, negative y equals 7, y equals negative 7. So my answer ends up being 2, negative 7. And the last one, we have 5x minus y equals 17, and 3x plus 2y equals 5. I see that my x's aren't about to cancel. I could multiply everything by 2 and get my y's to cancel. Or I can not use elimination, I can use substitution. If my board would, there we go. Sorry, my board's being a little glitchy right now. So I'm going to resolve this equation for y. So I have negative y equals negative 5x plus 17. But I don't like negative variables, so this is really y equals 5x minus 17. So I divide everything by a negative 1. Now if I keep going, I have 3x plus 2, 5x minus 17, because I just substitute that in for y. And now I keep solving from there. So I have 3x plus 10x minus 34 equals 5, or 13x minus 34 equals 5, 13x equals 39, x equals 3. And then I just have to replug that back in, so I have 5 times 3, so 15 minus 17, that means that we have y equals negative 2. Our answer is 3, negative 2. Okay, so when I ask you to identify, or you have problems like this where you have to identify the best way to solve it, and then solve it, I should see both what method you used written down. So if it's elimination, you have to put what symbol you used with it. So if it was addition elimination, you should put a plus sign next to it. If it was substitution, you need to write substitution. And then don't forget, all of your answers should have an ordered pair. Go ahead and try this one on your own and see how you do. Hopefully you determined the best method was substitution, and then you ended up with 4, 3 as your ordered pair. All right, our second example, we were talking about Ace Car Rental rents a car for $45 and 25 cents per mile. Star Car Rental rents a car for $35.30 per mile. How many miles would a driver need to drive before the cost of renting a car at Ace Car Rental and renting a car at Star Car Rental were the same? So first, let's talk about what would the equation for Ace Car Rental be. Our cost would equal, we have 25 cents per mile, and we're charged $45. So we're going to add that on no matter what. Star Car, our cost is represented by 30 cents per mile plus the $35. So we have a y equals and a y equals. So what we can do is set them equal to each other. So we have 0.25x plus 45 equals 0.30x plus 35. If we subtract 0.25x from both sides, I have 0.05x plus 35 on the right-hand side and 45 on the other. If I keep going from there, I subtract 35 from both sides, I have 10 equals 0.05x. And 0.05x, in order to get that by itself, I'm going to have to divide by 0.05x on both sides, and I end up with 200 equals x. So that means once each car has driven 200 miles, they equal out in price. But what is that price? Let's figure that out. So if we do 0.25 times 200 plus 45, that's 50 plus 45, or $95. If I were to plug that same number in for Star Car Rental, I would end up also with $95. So that is how you would set up your equations, and then we use substitution and we finish solving. Why don't you go ahead and finish solving this problem on your own. Good luck. Hopefully you determined that it would take 4 days to even out. Okay? If you have any questions about lesson 6.5, please be sure to ask. Have a good day.